None of us knew this until recently, but our solar system has some shocking secrets. Let's dive in. Our journey begins with the very formation of the solar system around 4.6 billion years ago. Imagine a vast, swirling cloud of gas and dust, known as a solar nebula, floating in the Milky Way galaxy. This nebula, under the influence of gravity, began to collapse in on itself, spinning faster and faster, eventually forming a flat, spinning disk. At the center of this disk, the Sun was born, igniting with nuclear fusion and becoming the brilliant star we know today. Our solar system's history is like a cosmic soap opera, full of drama and unexpected twists. As the Sun formed, the remaining material in the disk began to clump together, forming planetesimals, the building blocks of planets. These planetesimals collided and merged, growing larger and larger, eventually forming the planets, moons, and other celestial bodies that make up our solar system. But this process was far from smooth. It was chaotic, with countless collisions and near misses shaping the final layout of our solar system. Understanding this history helps us grasp our place in the universe. By studying the formation and evolution of our solar system, we can learn about the processes that led to the creation of Earth and the conditions that made life possible. This knowledge also helps us understand other planetary systems in the galaxy, providing clues about the potential for life elsewhere in the universe. But what if everything we thought we knew is only half the story? Recent discoveries and theories have challenged our understanding of the solar system's history, revealing a much more complex and dynamic picture than we ever imagined. For example, the discovery of exoplanets, planets orbiting other stars, has shown us that planetary systems can be incredibly diverse, with a wide range of configurations and characteristics. Common misconceptions abound, like that our solar system is a stable, unchanging place. In reality, it's a dynamic, ever-evolving dance of celestial bodies. The planets and other objects in our solar system are constantly moving, influenced by the gravitational pull of the Sun and each other. Over time, these gravitational interactions can cause significant changes in the orbits and positions of celestial bodies, leading to a constantly shifting and evolving solar system. In reality, it's a dynamic, ever-evolving dance of celestial bodies. For example, the orbits of the planets are not perfectly circular but elliptical, and they can change over time due to gravitational interactions. Additionally, the solar system is filled with countless smaller objects, such as asteroids and comets, which can be influenced by the gravity of the planets and the Sun, leading to complex and unpredictable movements. Scientists face monumental challenges in piecing together this cosmic puzzle. They use a variety of tools and techniques, from telescopes and spacecraft to computer simulations and laboratory experiments, to study the solar system and its history by analyzing the composition and behavior of celestial bodies. Scientists can infer the processes that shaped them and the events that occurred in the past. Let's talk gravity, the invisible puppet master. Gravity is the force that governs the motions of celestial bodies, shaping the structure and dynamics of the solar system. It is responsible for the formation of the Sun and planets, the orbits of moons and asteroids, and the interactions between different objects in space. Without gravity, the solar system as we know it would not exist. It's the force that shaped our solar system from a swirling cloud of gas and dust into the planets we know today. As the solar nebula collapsed under the influence of gravity, it began to spin faster, causing the material to flatten into a disk. Within this disk, regions of higher density formed, eventually leading to the creation of planetesimals and ultimately planets. Gravity also played a crucial role in the formation of moons, as smaller objects were captured by the gravity of larger planets. But major events like asteroid impacts and planetary collisions have also played a crucial role. These events can have dramatic effects on the structure and composition of celestial bodies, leading to the formation of craters, the creation of moons, and even the alteration of planetary orbits. For example, the Moon is thought to have formed from the debris of a giant impact between Earth and a Mars-sized object, while the craters on the Moon and other planets are evidence of past collisions with asteroids and comets. Here's where it gets really mind-blowing. Recent theories suggest a potential ninth planet lurking at the edge of our solar system. This hypothetical planet 9, if it exists, could be a massive icy world located far beyond the orbit of Neptune, Its presence could explain the unusual orbits of certain distant objects in the Kuiper Belt, a region of the solar system filled with small, icy bodies. This hypothetical Planet 9 could explain the strange orbits of distant objects. These objects, known as trans-Neptunian objects, have orbits that are highly elliptical and tilted relative to the plane of the solar system. The gravitational influence of a massive distant planet could account for these unusual orbits, providing a possible explanation for their behavior. And then there are comets. These icy wanderers might hold the keys to understanding the early solar system. Comets are thought to be remnants from the formation of the solar system, preserving the original material from the solar nebula. By studying the composition and behavior of comets, scientists can gain insights into the conditions and processes that existed in the early solar system, shedding light on its history and evolution. So, what does all this mean? It means that our solar system is far more complex and dynamic than we ever imagined. It is a constantly changing, mysterious expanse that scientists are still trying to fully understand. By studying the solar system and its history, we can learn about the processes that shaped it, the events that occurred in the past, and the potential for life elsewhere in the universe. Our solar system is far from being a static, predictable place. It is a dynamic, ever-evolving dance of celestial bodies influenced by gravity, collisions, and other forces. The planets and other objects in the solar system are constantly moving, changing their orbits and positions over time. This dynamic nature makes the solar system a fascinating and complex place to study, with many mysteries still waiting to be uncovered. It's a constantly changing, mysterious expanse that scientists are still trying to fully understand. Despite the many advances in our knowledge of the solar system, there is still much we do not know. New discoveries and theories continue to challenge our understanding, revealing new aspects of the solar system's history and dynamics. As we continue to explore and study the solar system, we can expect to uncover even more secrets and surprises. As we continue to explore, who knows what other secrets we'll uncover? With new missions and technologies, we are constantly expanding our knowledge of the solar system. From robotic spacecraft exploring distant planets and moons to telescopes peering into the far reaches of space, we are on a never-ending quest to understand the solar system and its history. Each new discovery brings us closer to unraveling the mysteries of our cosmic neighborhood. Comment below with your thoughts on the solar system's hidden history. What do you find most fascinating about the solar system? Do you have any theories or questions about its history and dynamics? We would love to hear your thoughts and engage in a discussion about the wonders of our solar system. And don't forget to check out our next video on space exploration. We will continue to explore the mysteries of the solar system and beyond, delving into the latest discoveries and theories about our cosmic neighborhood. Stay tuned for more exciting content and join us on this incredible journey through space.